Afterwards, we have already exposed a Helm chart for you that pretty much showcases how you can take advantage of all of the features in Compliant Kubernetes. Let me zoom it. And so let me just quickly go through this Helm chart and show you what capability it exposes of Compliant Kubernetes. And by the way, fun fact, the Helm chart of our .NET example is pretty much just a symlink to the Helm chart of the Node.js application. So this really shows that, once you have done properly Dockerize your application, that's pretty much done for it. Afterwards, it's just copy pasting and maybe a little bit of fine tuning, but that's it. So then I can show you, for example, that, here we run the application with replica count of 1, but go through a go live checklist. You might actually determine that it's better for you to use a high replication count, maybe 2 or 3, like I said, in order to tolerate node failures and no restarts with basically 0 downtime. Here we also, for example, said that, well, it's the port 3000 where your application is being exposed. So that's also something you need to be mindful about. And afterwards, here you just need to configure the ingress properly. And with these annotations, for example, that's all you need to do. And then 2 components which are inside the Compliant Kubernetes environment, the ingress controller and Let's Encrypt, the certificate manager, will automatically talk to Let's Encrypt and make sure that provision a certificate and ensure TLS termination of your application. Then we also recommend you to do proper capacity management and actually declare resource requests and resource limits for your application. And this is very important because you might be able to, let's say, fool yourself in believing that this application fits in the Compliant Kubernetes environment and that, oh, the pod is scheduled, how great. But if you don't have these, then you pretty much risk just not allowing Kubernetes to do proper scheduling, not allow it to properly take into account capacity management, and then you might run out of capacity without realizing it. So it's better to have rather generous limits and realize that the pod is unschedulable before entering production, rather than trying to just squeeze in another container and see if it fits the environment. And then you should enable
just a question for the resource requests. If maybe I have a new application or something like that, then I don't really know what values I should put in for the CPU and memory. Is there a good way to find out what kind of resource requests you should put on your pods?
So there are 2 scenarios for this case. Either you are porting an existing application to Compliant Kubernetes, or you have a greenfield project, and let's say this is your first application you run on top of Compliant Kubernetes. In case you are porting an existing application over to Compliant Kubernetes, then you can either use historic values to take this decision, or you could, for example, use your existing application to create some traces, so something like a synthetic workload, and then actually run some load testing against the application hosted on Compliant Kubernetes. Now, the more tricky scenario is what do you do with a greenfield project, right? This is the first time that this kind of application was written. You have no clue if it's going to be popular, or if nobody's going to, or if everybody's going to ignore it. So in that case, I think your crystal ball is as good as mine. But what I would recommend you is just to have a very honest discussion with the product manager or the product owner, and just tell them okay, we don't know how popular this product is going to be. Usually what happens is that you might be able to negotiate a slow rollout, right? Like you first have an alpha program where you roll it out to a few selected users. Then once you gain confidence in that, you will roll it out to a wider audience, so it enters beta testing. And of course, the primary reason for doing that is to make sure that your users are properly understanding the application and that you don't have any outstanding bugs. But this is also an excellent opportunity to figure out if you have properly sized the capacity of the environment, if you have properly set the resource limits of your application. Did that answer your question, Simon?
Yeah, definitely. Thank you.
And in order to know whether your application is struggling for capacity or is actually sized properly, we recommend you to enable a service monitor. So service monitor is a small object in Kubernetes that pretty much tells Compliant Kubernetes that all of the metrics from your /metrics endpoint or to be collected and shipped over to a quite complicated monitoring stack, which then afterwards allow you to create fancy dashboards and visualization based on your metrics. In case you want to set alerts based on your metrics, then the user demo also includes a Prometheus rule. So this allows you to, for example, alert if there are more users that you're expecting, or alert if, say, a certain endpoint takes more than 1 second to respond and you kind of expect it to respond within 1 second, and so on. Or if you have too many 500 errors or 404 errors, those can also be indicators of an error, and that requires usually some kind of human attention while the applications are in production. In case you want to have extra resilience, we can set up a compliant Kubernetes environment that spans several data centers or several zones. So as, for example, extreme weather taking down one data center doesn't affect the other data center. But this is really not useful unless your application is also spreading across the 2 zones. And in order to instruct Kubernetes that your application will be spread across 2 zones, these are the lines that you should then comment to obtain that effect. Finally, for extra security, we suggest you to enable a network policy. So this is a little bit like the firewall in compliant Kubernetes. If you're coming from a VM world, this is a bit like your security groups, or maybe you have heard of IP tables. Now, network policies enable you to do that. However, since containers are often created and destroyed and recreated and redestroyed, you cannot really say source IP should be allowed to talk to destination IP. Rather, you select them based on namespace labels or based on pod labels and so on. And so this is the configuration of the Helm chart that we're suggesting you to start with. We don't believe that this will fully satisfy your use case, but I strongly believe that it should be 95% of what you're looking for. And it should definitely help you get started with compliant Kubernetes and make the best benefits out of it. And we're extremely happy to get your feedback on what else is missing from this example, so as to allow you to succeed on your journey to port your application to compliant Kubernetes.